All right, we are looking at section 1.2, the first day of it. We are going to focus on solving equations here. The very first ones should be pretty basic. We're just looking at solving a linear equation in one variable, things you've been doing since Algebra 1. But then we're going to start looking at how do we solve them if they have fractions. We have a technique that will allow us to get rid of those fractions, make it easier. And then we're also going to look at what happens when that fraction has a variable in the denominator. Okay, because there's some extra things we have to worry about. All right. So what are the difference between these two examples? The one on the left versus the one on the right. What do you see that's different about them? Okay, the one on the right, there's an equal sign. What do we call it if there's an equal sign? We're making it too hard, right? If there's an equal sign, it's an equation. All right, so if there's an equal sign, we call that an equation. Can we solve it? Could we get a value for x? Yeah. Yes. All right, so an equation, we can solve the problem, we can find the value for x. How is the first one different, the one on the left? There's no equal sign, so instead of it being called an equation, it's called what? Starts with an E. No? We are tired on Friday here? All right. First one's called an expression. It doesn't have an equal sign. Is there anything we can do? Can we solve it? We can simplify it, right? We can combine like terms, do that kind of thing, simplify it down, but we cannot solve it. Common mistake is that students want to insert an equals 0 on the end of things. All right, if it's not given to you as an equation, you can't solve it. The most we can do is simplify them. So our focus today is on solving those equations. Our steps, we simplify each side by removing grouping symbols and combining like terms. Grouping symbols, typically parentheses, right, used to show maybe that you have some distributing to do, that type of thing. We want to collect all variable terms on one side and everything else on the other side. We want to isolate that variable and solve, and check our proposed solution in the original equation. Notice that one's underlined. It's extremely important that you check your solution. Make sure it works, but you have to check it in the original problem, not any piece along the way in your process. Okay, it always has to go back to the first one. All right, so at your tables, I want you to solve the first two. Don't go beyond that, please. Just solve the first two, and then we'll check. All right, for the first one, did you subtract 3 from both sides and divide by 2? And you got a 7? Did it work? Did you check it? Yes, it works. 2 times 7 is 14, plus 3 gets us the 17. All right, so it does work. Notice here, it says to put your answer as a solution set. For these first few questions here, we're going to get just a single answer. So it might seem like, why can't we just write it as x equals 7? But we are going to be solving things where we might get more than one answer. Okay? So we typically put it in that set notation with those set brackets. Okay? Our second one, you subtracted 5. And divided, so you got a 6. Yes, did it work? Yes, so then we put it in that set bracket. We say our solution set contains the number 6. How are the next two different from the first two? They look more complicated. What do we have to do? There's some distributing. There's some like terms we need to combine. Yes? All right. So first one, we distribute the 2. We end up with 2x minus 6. There's still the minus 17 on that side. On the other side, we have 13, and we're distributing what? a negative 3. So negative 3x and negative 6. Watch when you have to distribute that negative. Combining like terms, negative 6 and negative 17 would get us this 2x minus 23. On the other side, combining the 13 minus 6 gets us a 7 minus 3x. So we've distributed, we've combined like terms. Now we need to get variables to one side. Does it matter which side we move them to? No. All right. Let's say we add the 3x over here to the left side. We now have 5x's. Can we add the 23 at the same time to the other side? We end up with 30, which means x would have to be a 6. Yes? When you check that answer, you have to put a 6 any place there's an x. Okay? So on the left side, 6 minus 3 is 3. 3 times the 2 is 6. We get 6 minus 17, which is negative 11. On the other side, putting a 6 in there, 6 plus 2 is 8, times the 3 is 24. Is 13 minus 24 the same thing? So if both sides get us the same answer, we know that it works. We would put our answer as 6 in those set brackets. Okay? I'm going to pause the recording. I want you guys to try question D. All right, checking your work. Did you get a solution of 5? Yes? Did you check it in the original problem? Does it work? Okay. Our next set of questions involve fractions. These first two are still considered linear equations because there's no variables in the denominator, right? It's just like saying our coefficients would be a 1/4 and a 1/3 instead of integers, okay? But we don't want to deal with fractions if we don't have to. When we solved or simplified, I should say, a complex fraction in our last chapter, we eliminated all of those little denominator pieces by multiplying everything by an LCD, a common denominator. We can do that same thing here. Okay? So looking at our first question, what would the common denominator be? I see a 4 and a 3. I'd have to use a 12. Okay? We're going to multiply all three of these terms by a 12. Okay? Because all your denominators are factors of 12, we're going to be able to cancel them out. All right? So for this first one, the 4 goes into 12 how many times? 3. So we would have a 3 times this x plus 2. I would like you to get in the habit of not doing that multiplication in your head right away and just writing it like that. I'll explain why in a little bit. This next one, the 3 here goes into 12 how many times? 4. So now we have minus 4 times the x minus 1 piece. Most common mistake is students forget to multiply the 12 to that other side of the equation. You have to multiply all the pieces by 12. So we do have to distribute the 12 to the 2, which gets us a 24. Okay? Now, the reason I asked you not to try to multiply it all in your head as you go, right here, that minus sign throws things off for a lot of people. When we distribute, the first term becomes 3x plus 6. What do we get for the second half of that? We get a negative 4x and we get a positive 4. And most students get the wrong sign on that piece, all right, if they try to do it all in their head. Combining like terms, 3x minus 4x gets us negative 1x. The 4 and 6 can be combined to be a 10. Subtracting the 10 over gets me 14. How do I get rid of the negative? Divide it out. It's just a negative 1. So x ends up being negative 14. All right. Checking that. Because we have some fractions, it's going to take a little more effort to check it, but we still can do it. put a negative 14 in anywhere there was an x. Okay? Negative 14 plus 2 gets us negative 12 divided by 4. Gets me a negative 3. Then I have a negative 14 minus 1. That's negative 15 divided by 3 is negative 5, but we're subtracting that. And we're supposed to get a 2. Does it get us a 2? Okay. So our solution here would be a negative 14. All right. What is our common denominator for the next one? We need a number that 4, 14, and 7 all go into. 28? Okay. Let's times everything by 28. So, multiplying 28 to the first fraction. 4 goes into 28 how many times? So we end up with 7 times an x minus 3. When we distribute to this one, what do we get? 14 goes into 28 2 times, so we get 2 times 5. And then we are subtracting, and when we distribute to this last term, 7 goes into 28, so we have 4 times the x plus 5. Notice in doing this process, we have eliminated all our fractions, right? And we just have a nice, easy equation to solve. Distributing gets me 7x minus 21. 2 times 5 is 10. Distributing a negative 4 gets me negative 4x minus 20. 10 minus 20 is the same as negative 10. So we can simplify that down a little bit. And then getting variables to one side. I can add 4x over to the left. That gets me 11x's. I can add 21 over here. Gets me 11, which means x has to be 1. Okay? Checking that. Plugging a 1 in for our x's. 1 minus 3 gets me negative 2. Negative 2 fourths on that side. On this side, we've got 5 14ths minus, and putting a 1 in, we get 6 sevenths. 6 sevenths would be the same as what? 12 14ths. So 5 14ths minus 12 14ths is negative 7 14ths. Negative 7 14ths is the same as negative 1/2. Negative 2 fourths is negative 1/2. So it does stay balanced. So solution is just the 1. All right. How are these different from the fraction equations we just solved? Variables in the denominator. Good. Variables in the denominator. What did we have to do in our last chapter? Anytime we had a variable in the denominator, we had to state what? Excluded values, right? We had to make sure that x can't be something that would make that denominator 0. We have to watch that here as well. Because, for example, if I say x can't be 5, and then I solve my equation and it says x is supposed to equal 5, that can't work. All right? So you can end up with ones here where there's just no solution. The only answer you got isn't really going to work. We get those extraneous ones because in this process of eliminating all these denominator pieces, we forget that there's some values we can't use. So we solve the equation. It's not that we've solved it wrong, but putting it back into the original one isn't going to work. So we do have variables in the denominator, which means we have to worry about those excluded values. So before we do any solving, take a minute for each question and list what those excluded values will be. All right, so first one, what excluded value would we have? 0. X can't be 0. Jot it down somewhere near there just to help us remember. We can't have 0 for an answer. What would our common denominator be if we have an x, a 5, and a 2x? Okay, so we're going to times everything by 10x. When I distribute it to my first fraction, the x's are going to cancel out, and I just get 10 times 1. Okay? When I distribute it to this fraction, I can reduce the 10 and 5 to become a 2. There is still an x there. So I have 2x times this 1, or 2x. For my third fraction, what happens when I take 10x and divide it by a 2x? X's cancel out and turns to a 5, you said. Agree with that? So we end up with 5, but that 5 has to get multiplied to that 3. Yes? All right. Now it's a basic linear equation to solve again. Okay. So it started out as a rational equation where we had fractions with variables in the denominator, and now we've eliminated that. Subtracting our 15 to the left gets me negative 5. Dividing gets me negative 5 halves, or negative 2.5 if you want to put it in that form. Is that one of my excluded values? All right. Then we're going to go ahead and put that down as our answer. We can check these just like we checked the other ones. All right. The biggest thing you're going to see is when the solution you get is actually the value you have to exclude. Okay, so you need to watch for those. I'm going to pause the recording. I want you guys to try at your tables. Question B. What's our LCD? Good, 18x. What's our excluded value? All right. Timesing by 18x. 2x goes into 18x 9 times. 9 times 5 should be 45. In our next fraction, 18 goes into 18x and just leaves us with an x. X times 17. And then the last one, 3x goes into 18x 6 times. 6 times 1 is 6. We good so far? All right, adding 6 over here gets me 51. And dividing gets me what? 3. Is 3 my excluded value? No, so assuming I didn't make any little mathematical errors, it should work. But again, you can check it. If we put a 3 in there, we end up with 5/6 on that side. We've got 17/18 minus 1/9. 1/9 is the same as 2/18. So 17/18 minus 2/18 would be 15/18. Does that reduce to 5/6? Okay, so correct solution is a 3. All right. We still have a rational equation here because we have variables in the denominator. What's my excluded value going to be? Okay. So x cannot equal a 3 in this one. Now, the denominator is a little more complicated because instead of just a nice little monomial, we have a binomial. Our common denominator would have to be an x minus 3. So we need to distribute that x minus 3 to all of those terms. What happens when I multiply it to the first one? Yep, denominator is going to cancel that x minus 3. We just get a plain x. Same thing's going to happen here. The x minus 3's drop out, and we just have a 3. But the 9 just has a denominator of 1. So nothing's going to be able to drop out. We end up with having to take 9 times the x minus 3. Distributing. We get 9x minus 27. Combining the 3 and the negative 27 gets me 9x minus 24. Then what? Subtracting a 9x to the left ends with negative 8x, which means when I divide, I end up with x being 3. But we said at the very beginning, x can't be 3. So because it ends up creating a 0 in that denominator, it's not going to work. It was the only possible answer I got, and it doesn't work. So I say no solution, or I can use that empty bracket symbol to mean there's no answer. Either symbol's fine. You don't have to put both down. You can write it out, no solution, yep. No, that's fine. As long as you've identified that there isn't an answer. All right, for D, I do want to think of this as 2 times x plus 3. Just like in our last chapter when we were getting common denominators and things like that, we had to think of it in factored form. So our common denominator gets a little more complex here. What are my excluded values? -3 or 2. Okay. My common denominator that I have to multiply everything by, I need an x plus 3 for that first fraction. I need a 2, just a plain 2, monomial, to help with my second fraction. And for my third fraction, I need to have an x minus 2. So we have a few extra pieces here that we have to worry about, but the process is the same. When I distribute to the first fraction, this 3 over x plus 3, what drops out? The x plus 3's. That means I am left with a 2, an x minus 2, and a 3 that have to be multiplied together. I'm going to put the 2 and 3 together just as a 6, and I'm saying that 6 has to get multiplied to that x minus 2. Okay? We'll clean that up in a minute. When I distribute to the second fraction, the 2 and the x plus 3 both drop out. I still have an x minus 2 and the 5, so those are going to get multiplied. And then for my third fraction, the x minus 2 piece drops out, so those are gone. I have 1 times 2 times x plus 3. Questions on how I ended up with those pieces? All right, distributing. We get 6x minus 12 equals 5x minus 10 plus 2x plus 6. Okay. Combining like terms on the right-hand side, we end up with 7x minus 4. All right, getting x's to one side, I can subtract the 6 of them over to the right, which leaves me 1. And adding the -4 over to the left gets me a -8. Was that one of my excluded values? No. All right, so solution is -8. All right, I'm going to pause the recording again. I want you guys to try this last one at your tables. All right. Excluded values. Thank you. -3 and 2. Common denominator. This is going to factor into the same two pieces we have on the left side, right? So our LCD has to have both of those pieces. All right. So I need to distribute to all of those. For the first one, the x plus 3's will drop out. We get 6 times x minus 2. Watch that we're subtracting here. In our second fraction, the x minus 2's drop out. We have a 5 and an x plus 3 left over. And in the third fraction, all of that denominator drops out. We just have the -20. Everybody with me so far? Okay. Distributing, we've got 6x minus 12. Over here, be careful. We get -5x minus 15. Combining like terms, we end up with x minus 27. And then adding the 27 over, we get a 7. All right. It's not one of my excluded values. Again, you can plug it in and check it. If it were a test question, I would definitely do that. Make sure you catch if you made a little mathematical mistake somewhere along the way. Your assignment for section 1.2a. It's on page 118. You're doing 1 to 13 odd. and 25 to 49 odd. Obviously, there's some work to be done to get to those answers. So simply writing the answers from the back of the book isn't okay.